wabarakatuh. Good morning, everyone.
Waalaikumsalam
Waalaikumsalam
warahmatullahi
warahmatullahi
wabarakatuh.
wabarakatuh.
Good morning, sir.
How are you guys today?
Fine, sir.
Fine, sir.
Okay, glad to hear that. Before we start into the lesson, let's start praying. Please, one of you to lead the pray.
Okay, okay, sir and guys. Before we study, let's pray together. Praise God. Finish.
Okay, now let's check attendance. Does anybody already attend the class?
Attire not yet, sir.
Why, Anand? Do you know why?
We don't know because we already sent her message, but she didn't read.
Oh, okay, maybe we can just wait for Ataya to
Okay,
join.
sir.
Of the material chemical equilibrium.
Okay, sir.
Okay, sir.
Okay, sir.
Does anyone still remember what material did we study at last week's meeting about equilibrium?
Excuse me, sir. Last week we have studied up on the material about equilibrium, heterogeneous and homogeneous equilibrium.
Yeah, right. So after last week we studied heterogeneous equilibrium and homogeneous equilibrium. Today we will proceed to the next material, namely the equilibrium constant. Before that, to test your understanding of equilibrium, we are going to play a fun game through online game service called Quizzes. I will give you a code to play the game. The game is about last week's material.
Wow. Okay, sir. That's interesting.
Wow, I'm very interested.
Yes, indeed, it really is. Now, you can open up your cell phone or laptop and type on your browser quizzes.com, log in with your email and type your name and enter the passcode.
Okay, sir.
Okay, sir.
Where is the code, sir?
Wait,
Okay.
okay, here is. Wait. Okay, wait. Mm, okay, and here is the passcode for you to join the game.
Okay. Okay. Okay.
Okay, it's still just Anam who already joined the game, still waiting for the others. Now Angel. Still waiting for Desti and Iqbal, who has not yet joined the game.
Come on, guys. I cannot wait to play the game. Hmm.
Come on, Iqbal and Desti. Time is ticking, guys. Hurry up. Okay, now Desti already joined. Iqbal. Iqbal hasn't joined the game. Iqbal, can you hear me? Or you have a problem with your connection or something? Can you hear my voice? Iqbal. Oh, okay. It's already complete. Now we start into the game. Are you guys ready?
Yes, sir. Ready.
Okay. The game is begin. Okay. Angel top the score with 990 and Desti in second position with 980 points. Angel number one. Okay, now Iqbal lead the point. Come on, guys, keep fighting. Okay, Angel already answered 4 questions and lead the score with 3000, 3019. Oh, now 4000, 4020. Anan in the second position, Iqbal in third position, and Destin fourth or the last position. Okay, still Angel. Okay, still Angel, little points. Okay, now with 70,180. Anan with 3,1930. Oh, Iqbal now in the second position. Okay, still Angel. It looks like Angel will be the winner, but Iqbal could be another danger for Angel.
Yay!
Angel already finished the game with 7,180 points. While in the second place with four 5,530. Anan finished with in the third place with 4,200. Still waiting for Desti. Okay, we will waiting for Desti to finish the game.
Okay, sir.
Okay, sir.
Come on, Desti, hurry up. Be quick. Desti, come on. Okay, for the temporary winner of the game is Angel.
Yoo, congratulations, Angel.
Congratulations, Iqbal
Thank
in the
you.
second. Yes, Angel with more than 700 points, and Iqbal in the second place with more than 5,000 points, and Anand Zahra in the third place with more than 4,000 points. Disti, can you hear me? Disti.
Desti Iqbal, maybe you can on cam.
Disti, where are you? Okay, maybe because Disti not respond. Maybe we can continue to
I'm
our.
sorry.
Oh, okay. Okay, we continue our study to our lesson today. To start, okay, wait. To start our study, please observe the table.
Okay, sir.
Okay, wait. The table will be okay. Okay, here is the table of concentration of the equilibrium from the reaction N2O4 in gas phase in backward and forward equilibrium reaction to NO2 in gas phase at 25 degrees Celsius. Okay, and there are initial concentration, concentration equilibrium, and comparison of concentrations at equilibrium. Now I will give you around 2 minutes to observe the table, and I will ask you about what information do you get from the table. Okay, I will give you 2 minutes to observe the table. Okay, now it's already 2 minutes. What information do you get from the table? Come on, guys. What information do you get from the table?
Excuse me, sir.
Yes.
After I observed the table above, I obtained information that after equilibrium, the concentration of NO2 tends to decrease, and the concentration of N2O4 tends to increase.
Okay. Yes. Well, is there anyone else who obtained the other information?
Yes, sir. I would like to add information. So, after I observed the table above, I obtained the information that the ratio of concentration at the moment equilibrium, concentration of NO2 per concentration of N2O4 give various values, while at concentration of NO2 square per concentration of N2O4 give almost the same value.
Yes, it is true. At the time of equilibrium state, the concentration of product or NO2 will tend to decrease over time, and when the state is equilibrium, the concentration of reactants or N2O4 over time it will tend to increase. Then when equilibrium, the concentration ratio at equilibrium, concentration of NO2 per concentration of N2O4 produces various value which is nearly zero point 0.1 yield 0.1 and at a ratio of concentration at equilibrium per concentration N2O4 yield nearly constant values is average more 0.63 multiply 10 to the power of minus 3. Thus, what can you get from the ratio? at equilibrium, concentration NO2 square per concentration of N2O4. Guys,
Sorry, sir. Ataya won't
what
join.
can you get what can you get from the ratio of concentration at equilibrium?
Sorry, sir. Ataya has joined
Oh, okay,
the
Ataya,
group.
welcome. Ataya, can you hear me? Okay, this is not responding.
Sorry,
Okay,
sir.
yeah, why?
Maybe you can repeat the question, sir.
Okay. Thus, what can you get from the ratio of concentration at equilibrium, the concentration NO2 square per concentration of N2O4?
Yes, sir. From your explanation, I found that the ratio of concentration is in equilibrium NO2 square per N2NO4 is a fixed value.
Well, yes, that's right. Is there anything you want to ask?
Sir, I want to ask, what is the constant value of the equilibrium concentration at uh, concentration of NO2 square divided by concentration of N2O4?
Well, to answer a question from from your friend, pay attention to a reaction. The reaction, as we can see from the screen, there is a reaction.
Sir,
Yeah,
from the reaction above, where A, B,
little.
C, and
I
D.
am not. I have not explained it yet. Wait for me. Okay, as we can see from the screen, there is a reaction. Uh, on the left side, it is the reactants, and on the right side, it is the product. The lowercase letter represent the coefficient from the reaction, and capital letters represent the substances. So, what do you know from this reaction?
Okay, sure. From the reaction above, where A, B, C, and D is the stoichiometric coefficient for each of the reacting species A, B, C, and D.
Well, from these coefficients can be obtained a constant or equilibrium constant. Okay, the concentration of C to the power to the coefficient and D multiplied with to the concentration of D with its coefficient per the concentration of A with its coefficient multiplied with the concentration of B with its coefficient. So what do you obtain from the equilibrium constant above?
I can answer the question, Mister. The product of concentration of the substance resulting from reaction is raised to the coefficient divided by the reactant to the power of coefficient.
Good job. Your answer is almost correct. The correct answer is that is an equilibrium state. The product of the concentration of substances resulting from the reaction is raised to its coefficients divided by the product of the concentration of reagent substances raised to its coefficient will have a fixed value. Therefore, the equation above is the law of mass action or the law of equilibrium or K. Is there any question?
Not yet, sir.
If you don't have any questions, now write down the equilibrium constant of the reaction in the experimental table.
Okay, sir, like we can see in the PowerPoint presentation, so K is equal concentration of NO2 square per concentration of N2O4.
Alright then, reaction that given above is correct. Now, please notice to the reaction given below. As we can see, there is a plus 2b backward and forward equilibrium reaction AB2. On the upper side, it is KF, and on the downside, it is KR. So, what kind of the reaction above?
I can answer the question, sir. After, take a look at is the reaction above same as the reaction rate. Sir,
Okay, if the above reaction is also the reaction rate, then which is the rate of progress?
I can answer the question, sir. The rate of progress is rate equal to Kf concentration of A and concentration of B equal.
Then the reverse rate is
the reverse rate is rate R equals to Kr times concentration of AB2.
yeah. Then if the equation rate F is equals with RR, what kind of result will you obtain?
If rate F equals to rate, then the solution is rate F equals to rate R Kf times to concentration A times to concentration B squared equals to Kr times to concentration AB. And then Kf divided by Kr equals to concentration AB divided, equals to concentration AB2 divided by concentration AB times to concentration AB squared.
Good job. If rate F is equals to rate R, you will get the result as above. Kf per Kr is equals with concentration of AB2 per the concentration of A multiplied with concentration of B to the power of 2, where Kf and Kr are rate constants for the forward and reverse direction, respectively. At equilibrium, what will happen to both rates if there are no net change occurs?
So the two rate must be the same, sir.
Yes, definitely right. So from the equation above, is there anything you want to ask?
Me, sir, from the above equation, will we obtain a new decision?
Good question. From the equation above, because Kf and Kr are constants at a certain temperature, the ratio is also a constant. Uh, the equation, as you can see at the screen, because it is a constant, it produces a new constant, namely Kc. So what do you think the Kc constant is?
Constant oxidation factor of the reactant state is our the same as Kr of Kf.
Sorry, Angel, maybe you can repeat?
Yes, we can hear your voice clearly, Angel.
Kc is a constant whatever the oxidation factor of the reactant state either as Kf or Kr.
Yes, that's a pretty good answer. So Kc is a constant regardless of the equilibrium concentration of the reacting species because this constant is always the same as Kf per Kr. The equation of two quantities is constant at a certain temperature. Because constant depends on temperature, the equilibrium constant must change with the changing temperature. Do you think that the constant will change again or
Sorry, sir, we
I
cannot hear
think
your
from the
voice.
above expression,
Sorry, Iqbal, can you turn off your video voice? I mean,
okay, Desti, maybe you can repeat your answer.
I think from the above equation, the equilibrium constant will give k less than 1, so the equilibrium will be more toward the left.
Yeah, good answer. So if k is less than 1, then the equilibrium will be more towards the left.
Miss Hazel, your mic is off.
Okay, can you hear me?
Yes, Miss.
I can hear you.
Okay, please notice the reaction below. N2O4 gas that was and follows makes 2NO2 gas. In the reaction above, what is the phase of each of the equilibrium components?
I can answer the questions, Miss. In the reaction above, the phase of each equilibrium component is a gas N2O4 and 2NO2 both have gas phase.
Correct. Thus, in each of the equilibrium components in reaction are gas. Both reactant N2O4 and product 2NO2 components are in gas phase. Is there any further question?
Miss, as we know from the phase reaction above, what does the reaction phase relate to the equilibrium?
After last week, we learned about heterogeneous and homogeneous equilibrium. In reaction above, is it included in heterogeneous or homogeneous equilibrium?
It's homogeneous equilibrium because in reaction above all the reactant states are the same.
Yes, that's right. It is included in homogeneous equilibrium reaction because the homogeneous equilibrium applies to reaction in which all reacting species are in the same place, namely as gas phase. In your opinion, if the equilibrium is in gas phase, can you calculate the concentration of the equilibrium components?
I think yes, miss. We can calculate the gas concentration, miss.
Good answer. If in the gas phase you can calculate the concentration, how do you calculate it? Is it not feasible?
Miss, I like to answer. I don't think it is possible to calculate the concentration of the equilibrium components if the reaction in gas phase, so all you can count is the pressure.
Now, yes, very good answer. So, in the active gas phase, what can be calculated is the partial pressure.
How do we calculate the partial pressure?
Good question. To answer your friend's question, observe the equation for the ideal gas below. If V equal to nRT, V equal to N plus V RT. If in a system the temperature is fixed in gas, what will the system pressure be?
Okay, Miss. I think when a system temperature is fixed, the pressure P of a gas is directly proportional in the concentration in moles per liter of the gas.
Well, that's right. At a fixed temperature, the pressure P of a gas is directly proportional to the concentration in moles per liter, and P is the concentration of gas in the room. Hmm. Take a look at a reaction below, as you can see on PowerPoint. From the explanation above, how is the partial pressure in each component?
I am Miss. I think D plus N divided by V is the concentration of gas in the room. Therefore, the ideal gas equation is PA equals to concentration A times RT, same as PD equals to concentration B times RT, same as PC equals to concentration C times RT, same as PD equals to concentration D times RT. So the equation for the reaction above is obtain PnO2 equals to concentration NO2 times RT. It goes same as for Pn2O4 equals to concentration N2O4 times RT.
Yes, very good answer. Mm, what about the KT determination? Guys, what about the KT determination?
Miss, I think the Kp set in the reaction above is Kp equal to partial pressure of NO2 equal and divide by partial pressure of N2O4.
Okay, that's right. At this point, do you have anything else to ask?
Me, miss, then what is the relationship between P and ideal gas?
Well, a good question. So after air very warm, then then Substitute it into the constant Kp equation. Now, try to substitute it into the constant Kp equation.
Okay, Miss. So I have subtitled the Kp equation and got the following result. Kp equal to concentration of NO2 RT divided by V equal
Sorry,
divided by
Iqbal, you mean square, not equal, to the power of 2 is square. Maybe you can repeat, Iqbal.
okay. I have subtitled the Kp equation and got the following result. Kp equal uh, concentration of NO2 RT divided by V and equal divided by concentration of N2O4 RT divided by V to the power of 0. And then because R and T are fixed, it is removed from the bracket so that it becomes Kp equal NO concentration of NO2 divided by V equal uh, divided by N2 concentration N2O4 divided by V the power of 0 times for RT the power of 2 minus 0.
Okay, you can see square not equals. The Kp equation obtained is as follows. Kp equals to concentration of NO2 per V square per concentration of N2O4 per V uh, times RT to the power of 2 minus 0. Okay. What new information can you get if the above equation Kp is related to the equilibrium constant Kc?
Sorry, sir. Sorry, miss. From the equilibrium constant Kc is the product of the product substance raised to coefficient of the product of reactant to the power of coefficient. Thus, in this equation, Kp is equal concentration of NO2 per V to the power of 2 per concentration of N2O4 per V to the power of 0 times RT to the power of 2 minus 0, or uh, concentration of NO2 per V to the power of 2 per concentration NO2 N2O4 per V to the power of 0 is a constant Kc, so that the Kp constant get the result Kp is equal Kc times RT to the power of 2 minus 0.
Yes, very good answer. Or in other words, the equilibrium constant Kc equation can be written in the following equation. As you can see on PowerPoint. Does anyone know what is the meaning of delta n from the difference of deviation result?
I want to answer you.
Okay,
Delta n is mole of the product minus mole of the reactant, or it can be like like this. Delta n equal B minus A. Delta n equal mole of the product minus mole of the reactant.
uh, okay. at the example of equilibrium reaction problem below.
I will answer the questions, please.
Okay.
According to the equilibrium constant, we obtain its concentration HI to the power of 2 divided concentration H2 times concentration I2 equals to 9 point, I mean 1.98 to the power of 2 divided by 0.243 times 0.146 equals to 111 because the calculate equation is greater than Kc.
Oh, that's right, Ataya. Because the system is not in equilibrium. As a result, some Hi will react to form more H2 and I2, lowering the equation value. The new constant is Qc. So, where is the net reaction occur?
We don't
We
know
don't
it
know it
yet,
yet.
miss.
After this, Miss Ella will teach you, guys.
Alright, to answer the question above, look at the picture below. Picture 1, picture 2, and picture 3. What information do you get from the picture above?
Okay, Miss, from what I observe, I get information that if the value of constant Kc is greater than the value of constant Qc, the reaction will be in product direction. Then, if the constant Kc is equal to constant Qc, then the reactant and product are in equilibrium. If the constant QC is greater than the Kc constant, the reaction will go towards the reactant.
Yes, absolutely correct. Because the constant Kc is greater than the constant value of Qc, the reaction will shift from the reactant to the product. Then, if the constant Kc is equal to the constant Qc, then the reactant and product are in equilibrium. If the constant Qc is greater than Kc constant, the reaction will shift from product to reactant. Then, according to the answer to the question that you have not answered, the liar is
Means if Hi will react to form more H2 and I2, then the reaction will occur from right to left, from product to reactant to reach equilibrium.
yes, very good. Because the constant Qc is greater than the constant Kc, the reaction will shift from product to reactant to reach equilibrium. So, after knowing the equilibrium constant for a particular reaction, we can calculate the concentration in equilibrium mixture from its initial concentration. For that, consider the sample question below. A mixture of 0.500 mol H2 and 0.500 mol I2 is placed in a 1 liter stainless steel box at 533 Celsius. The equilibrium constant Kc for the reaction H2 gas plus I2 gas forward and back to HI gas is 54.3 at this temperature. Calculate the concentration of H2, I2, and Hi at equilibrium. So, from the example question above, what do you know? Means mol H2 is 0.500 mol, mol I2 is 0.500 mol, volume of solution 1 liter, temperature 430 degrees Celsius, and K at the reaction is 54.3.
Then, how about its stoichiometry reaction?
The stoichiometry reaction is 1 mole of H2 reacting with 1 mole of I2 to give 2 mole of HI.
Correct. The in suppose if X is the reduction in consideration in concentration mole per liter of H2 and H and I2 at equilibrium. So how much X for the equilibrium concentration of HI must be?
Yes, Miss. If X is the reduction in concentration or mole per liter of H2 and I2 at equilibrium, the equilibrium concentration HI must be 2 times.
Then what change is concentration can you write down?
The reaction could be likely as follows. H3 in gas phase plus I2 in gas phase, forward and backward reaction, 2 2HI in gas phase, and then early reaction per mole, in moles was 0.500, 0.500, and then the last one is 0 mole. And then change was minus x plus 2x. From all of that, we can calculate the equilibrium work 0.500 minus x, 0.500 minus x, and then 2x.
Yes, very good. Then what is the known equation for the equilibrium constant Kc reaction?
Okay, Miss. The value of equilibrium constant Kc is 54.3. Then the equilibrium constant Kc is as follow. Kc is equal concentration of Hi to the power of 2 per concentration of H2 times concentration of I2.
Then, after obtain the reaction equation for the equilibrium constant Kc, what will we do next?
After we obtain the concentration equation to Kc, what we have to do is substituting the
Sorry, Angel, we cannot hear your voice.
then it okay repeat after we obtain okay okay repeat after we obtain the equilibrium constant reaction equation to Kc, what we have to do is substituting minus x and plus 2x into the equilibrium constant of Kc.
That's right. So, after you obtain the equilibrium constant Kc reaction equation, min x, and plus 2x are substituted into the equilibrium constant reaction equation Kc. Now, how do you substitute it? Does anyone want to answer it?
I am miss. We can substitute it like this. 54.3 equals to 2x to the power of 3 divided by 0.500 minus x times 0.500 minus x.
Alright, good answer. Then if the equation is like that, how do you get the value of x?
To get value of x, we can put the two set miss.
Well, yes, that's right. To get the value of x, we can get the two sides. Then how write down the equation?
So the equation is square root 54.3 equal square root 2x to the power of 2 divided by 0.500 minus x times to 0.500 minus x. Then the result after being root is 7.37 equal to x divided by 2x divided by 0.500 minus x equal 0.390 393.
Is the concentration of each component of the equilibrium can be calculated? What is the concentration in each component of the equilibrium?
At equilibrium state, the concentration can be as follows. For concentration of H2 is equal 0.500 minus 0.393 m is equal 0.107 m. For concentration of I2 is equal 0.500 minus 0.393 m is equal 0.107 m. And for concentration of Hi is equal to multiplied by 0.393 is equal 0.789 m, 86 m.
Yeah, yes, correct. The concentration on each component is concentration H2 equal 0.500 minus 0.393 m equal 0.107 m, and concentration I2 equal 0.500 minus 0.393 equal 0.107 m, and concentration Hi equals 2 times 0.393 equals 0.586 m. So after you studied the equilibrium constant, then what is the meaning of the value of equilibrium constant that you can get?
I miss, after we studied the equilibrium constant for a particular reaction, we can get the meaning of the equilibrium constant. The first is to predict the direction of the reaction, and the second is to calculate the concentration of equilibrium components.
Yes, correct. So after you studied the equilibrium constant, you can get the meaning of equilibrium constant. Namely, the constant can predict the direction of equilibrium reaction, and the second constant can determine the concentration of equilibrium component. Okay, is there anything else you want to ask?
No, mister, any advice for you for today's lesson?
No, miss.
Alright, if if nobody asks, I think it's enough for today's lesson. Good afternoon. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Waalaikumsalam
warahmatullahi
warahmatullahi wabarakatuh.
wabarakatuh. Good morning, Miss.
Yes.